Hi there. I'm Mike Barkazzi, a philosophy instructor at York University in Toronto, and this is my talk for the 95th joint session of the Aristotelian Society and Mind Association. So my talk today will be on how perception is experience of the past, or at least involves experience of the past. So normally, as you interact with the environment through your senses, you come to experience the here and now. What you perceive is what is around you presently. At least this is how experience introspectively strikes you. We might ask two questions. First, do we experience the environment itself? And second, do we experience it as it is now? For the first question, a lot of people think that we experience something like images or percepts and not the environment itself, but I will set this kind of dispute aside and just assume for simplicity that we do experience the environment itself. The second issue, though, will be the focus. Do we experience the environment as it is now? Historically, people have thought not, or at least that there are two well-known wrinkles here. The first comes from signal transmission lag. Simply, it takes time for things like light rays to get from reflected objects to your eyes. And the second is from the use of working memory in perception. So for instance, you see the sun not as it is in the here and now, but as it was 8 minutes ago, because that's the length of time it takes sunlight to get to you. And as far as working memory goes, you don't just experience what's happening now in this very instant, but you experience what's often called the specious present, a 1 or 2 second window stretching into the past. For example, if you watch a ball pitched at you, you don't just see the ball where it is at any one moment, but you see the whole past extended trajectory of the ball. But neither of these sorts of cases are what I'm interested in today. So I'm going to argue that there's a third way in which the past intrudes into perceptual experience. And my focus will be on prototypical successful object perception. For instance, cases where you're holding an object and looking right at it. In this sort of case, signal lag is negligible. And although, of course, your experience still includes the specious present, nothing seems to be amiss about this. So experience presents itself as including the last moment or two. And what I'm going to try to argue is that, in fact, in these cases, part of what intrudes into experience actually extends back further than that, further than what working memory alone would explain. So the main idea here, the starting point, is just that in addition to working memory, we have long-term mnemonic neural mechanisms which are integrated into our sensory circuits, the neural networks extending from our eyes, ears, and skin. And these long-term neural mechanisms, they take many forms. Perhaps the most prominent would be just long-term potentiation of synapses. Now, although James didn't know about long-term potentiation, the idea that somehow memory is involved in perception, in fact, long-term memory, goes back at least to William James. So here's a quote from one of his textbooks in 1892. He says that when we use our senses, the brain reacts by nerve fiber paths which the previous experiences have worn and which make us perceive the probable thing, i.e., the thing by which on previous occasions the reaction was most frequently aroused. Now, this quote here was part of what got me thinking about this. And so by the end of the talk, the view that I will advocate for very much is filling out this idea here from James. Of course, the use in memory in perception is not a new idea or has not gone unnoticed. Here are a list of other psychologists who have discussed the use of long-term memory in perception. So Ewald Hering in the 19th century talked famously about memory colors and explained things like color and shape constancy in terms of memory. The idea was that what we see in terms of color or shape is actually some kind of average of past instances of those colors and shapes. Wilder Penfield famously worked with epileptic patients and stimulated the cortex of these patients in medical surgeries. And famously, when he stimulated the cortex just downstream of the primary sensory cortices, he sometimes induced memory hallucinations. His patients would report seeing and hearing things that had just happened that morning or a few days before. Quite famously, Kosslyn, and somewhat less famously and more recently Albright, have argued that the neural correlates of consciousness actually result from a mix of bottom-up and top-down neural activity, the top-down activity being long-term memory-based activity. And most recently, Donna Addis has argued that there is a single neurocognitive system which assembles experience across not only memory and imagination, but also perception. So roughly across all of these psychologists, the idea is that present perceptual experience is shaped by past experience. Past experience via long-term mnemonic neural mechanisms like synaptic plasticity primes sensory neural circuits deep in the brain to repeat patterns of firing. Current sensory input, instancing bits and pieces of these patterns, reactivates them. The neural activity responsible for experience at any given moment then lies somewhere in the middle, a pattern of activity that's driven both by receptor input and reactivated long-term memory traces. So here's just a schematic diagram. We have the receptors on the right in the skin, eyes, ears, nose, tongue. Then we have some sort of neural network in between them. And somewhere higher in the network, we have long-term potentiation, which binds neurons together or wires them together in some kind of Hebbian learning or something like that. And the idea is that what we experience is determined by what happens in the middle of the network. So it results not only from the blue axons, the upflowing projections from the receptors, but also here in my diagram, the green back projections from those long-term memory traces. Now, the idea that somehow memory is involved in perception is not unique to psychologists. It has a long history in philosophy as well, although in philosophy, the same point is often framed in terms of imagination and not memory. So famously, Immanuel Kant argued that experience is not passive receptivity, as he put it, but an active synthesis of sensory input plus additional ingredients from imagination. More recently, Strawson argued that we need imagination to explain how we perceive two object instances as instances of the same object, as that sort of information is not inherent in the sensory input itself. More recently still, we have a number of philosophers working on this topic. So McPherson and Brown have picked up the idea of memory colors and how that is an example of imagination influencing perception. We have Nene and Kind discussing amodal completion, for instance, how we experience objects' backsides or their occluded parts. And they have cast this as another example of imagination filling in complete input. And also you might think that something similar happens with ambiguous figures like the Necker cube. And here again, this might look like a case where imagination is playing some role to resolve ambiguous sensory input. Now, I don't want to get hung up on this question of whether this is really imagination or perception. For my purposes, it just doesn't matter. So it doesn't matter how we type the process that uses memory traces in the processing of sensory input. All that matters, and everyone agrees on this, that memory traces are used in sensory processing. So there are things like long-term potentiation. These mechanisms wire together neural responses, and this leaves a memory trace which affects subsequent sensory processing. So now 2 questions. First, does the involvement of long-term mnemonic neural mechanisms and memory traces in sensory processing really entail that we experience the past while perceiving? And second, if so, what exactly from the past intrudes into perceptual experience? So, of course, you may just doubt that uh, the involvement of these sorts of mechanisms gets the past into experience. And even if it does, we need clarity on what exactly from the past is intruding into our present perceptual experience. So I want to start with what I take to be the argument against my inference, the argument against perception as experience of the past. So you might grant that long-term mnemonic neural mechanisms affect sensory processing, but that processing, you might point out, still functions to track and categorize present particular stimuli. So as we use our senses, our eyes, ears, etc., we are attempting to discover or learn about or track or categorize the here and now, what's in our environment around us now. And so you might think that memory traces affect which properties we attribute to present stimuli, but still, nonetheless, what we experience are simply present stimuli and the properties that our sensory systems attribute to them. And of course, properties, as opposed to their instances, are atemporal. They're not in the past or the future or anywhere. And so if this view is correct, then experience is exhausted by present particular stimuli and the atemporal properties which are attributed to them. In other words, there's no room for the past to come into experience, even if the past causally affects what we now experience. So while that argument, I think, is convincing on a first pass, it, I think, fails when we consider exactly how we experience properties. So properties are atemporal, but we don't experience properties in their true objective or Platonic forms. Instead, we experience properties through our sensory modalities. For example, what it's like to experience my pencil shape depends on whether I'm using my eyes or my hands. Now, this doesn't necessarily have to be some form of inaccuracy. The point just is that our experience of properties is flavored by our sensory systems, our neural systems, the way in which we have access to them. So whether I'm looking at the pencil or feeling the pencil affects exactly what gets into my experience. So my suggestion then is that these long-term mnemonic neural mechanisms are their own variety of perception or perceptual modality. So just as vision and touch afford distinct sensory modalities through which we engage and experience the environment, so too do these long-term mnemonic neural mechanisms. And just as, say, vision versus touch affects how we experience properties, so too do these mnemonic mechanisms. They give our experience a kind of temporal flavor. For example, as I look now at my pencil, I don't experience its color, cadmium yellow, as it really is in the moment. Instead, I experience cadmium yellow as it was in the past, on previous experiences, as I encountered it, or maybe as I remember it being. So the idea here is that each time we encounter a property, that encounter refines our neurosensory representations, that neural activity which is activated, which gives rise to our experience. So stored representations capture properties not as timeless abstractions, but as they've been encountered in the past. We can perhaps contrast here an ideal perceiver that doesn't have to perceive the environment through the limited or messy or contingent nature of human sensory systems with us. And of course, we're not that ideal perceiver. And so our representations, they're not ideal representations capturing the true nature of properties that we're perceiving, but instead they are shaped by past experience. For each property, there is a way that it has appeared on average in the past across many past interactions. Experienced properties do not appear as they might to an ideal observer, but in this average way, we've encountered them in the past. Now, to this sort of account, you might raise the following objection. You might claim that memory only gets involved when the receptor input is incomplete, indeterminate, or noisy. For instance, as in low light seeing or looking at ambiguous figures like the Necker cube on this slide. Hence, even if my account is true, you might object that it doesn't apply to prototypical successful cases of object perception, prototypical cases in which I look at some object, say, in my hands. Now, there's a few replies I want to make to this objection. The first is just to point out that receptor input is always incomplete, indeterminate, and noisy, even in prototypical successful cases of object perception. Still, nonetheless, we manage to perceive properties successfully despite this. So for instance, even though a quick glance at an object isn't enough to actually tell you its 3D shape, there is not enough information there in that momentary receptor input. Nevertheless, a quick glance is all you need to see the shape. And we don't think that this is unsuccessful perception or somehow defective. This is just the normal case of object perception. So even in these sorts of normal good cases of object perception, we have indeterminate, incomplete, and noisy input. The second sort of consideration is to think about the way in which all perception is inferential or computational. So all perception involves extracting information or properties from the receptor input. Well, how does that happen? Well, even in the good case, when all is going well, that happens via the synaptic connections in your sensory neural circuits. And of course, those synaptic connections are tuned via these long-term mnemonic neural mechanisms, like long-term potentiation and long-term depression. So in any case, these long-term mnemonic neural mechanisms are just part of the normal computational architecture of perception. They're not something special or separate from normal sensory processing. They are always involved. And in fact, there's good evidence that these mechanisms are involved very early in perception, for instance, even down into the primary visual cortex. So to summarize, when I look at the pencil I'm holding, whether under mesopic or normal lighting conditions, I don't experience its cadmium yellow as it really is in the here and now. To varying degrees, depending on the viewing conditions, I experience that cadmium yellow as it struck me in the past across previous viewings. So even prototypical successful object perception involves experience of the past. So for those interested, here are the citations for the slides. And otherwise, thank you very much for your time.